These slides are available in this bit.ly URL. So you can think like open source slides, OK? So you can get the slides and copy. Feel free to copy. There's no copyright here. By the way, who don't know me, my name is RAFAEL. I work at Red Hat as Director of Developer Experience. I've been working for Red Hat for 9 years. Started as a developer, I started as a consultant. Then I became a developer, a software engineer. And now I work as a Director of Developer Experience, which is essentially like a developer advocate, developer evangelist. So I go to conference, I talk to you, I understand what your needs are. Then I return to Red Hat and say, Red Hat, developers want this. And Red Hat attend your desires. And then I return to conference and say, this is what Red Hat has provided. These are the good things, the new things that Red Hat has brought to developers. Okay, but essentially, I'm a Java developer. This is what I do for life since the year 2001 to 2002. Okay, so let's start. Before you start developing microservices, you need to go through a kind of evolution process, okay? So the first thing that you need to do in your company, in the place that you work, is to reorganize your team to adopt DevOps practices, okay? So with DevOps practices, you can then have a elastic infrastructure, like for example in the cloud, something that you can grow or shrink based on the demand. And once that you have elastic infrastructure and DevOps practices, you can start to have automation with tools like Ansible, Chef, Puppet. Then you can start, because you have automation, you can have continuous integration and continuous deployment pipeline. Okay? And now that you have continuous integration, continuous pipeline, you will have advanced deployment techniques, which means that you can deploy more than once a week, more than once a day, sometimes more than once in an hour. Okay, that would be great. And if you have such agility, then you can have your first microservice. Yeah, who knows? You can become the next Silicon Valley unicorn. And let's think about it. Let's think about OpenShift and Kubernetes. With OpenShift, Kubernetes, and Istio, you will have a lot of unicorn love coming from this product. Because OpenShift, Kubernetes, and Istio can provide you elastic infrastructure, can provide you automation, continuous integration, and continuous deployment pipelines. But let's think what we have nowadays. We have our application, right? Our big and beautiful monolith. And inside our application, usually we have business boundaries, right? We have the sales, we have the finance, we have the security model. So our application is really divided in small modules. But there was a moment in time that we decided to take those business modules and create microservices, right? And the microservice is not only inside a single machine. We decided to spread them in a network of services. And because we have a network of services, we can have, each microservice has your own data, okay? We have multiple entries. And if we think microservice is equal distributed computing. Okay, it's nothing more than have an operational system with a JVM, with a service A, and we have another service B that's running on another JVM in another computer that we'll call service C that's is running another JVM in another computer in a distributed computing. So we tend to think when we distribute microservices, we tend to forget some things about distributed computing. we forget that we think that the network is always reliable, right? We think that there is no latency. We think that our bandwidth is infinite, that the topology will not change. We think that there is only one administrator that we can call if there is a problem, and that's not true, right? Sometimes we call the admin and he says, I'm not working this week. So it's another one problem. We think that the transport cost is 0 and also the network is homogeneous. And there are some principles of microservices. Microservices, they are built to be replaceable. That's the beauty of microservices. So to achieve more than one deployment a day, we need to build our microservices thinking that they can be replaced anywhere, at any time, any moment. And to achieve that, we need to focus on the API. We also need to think about evolutionary design. So if we replace the service B, service A can continue accessing the new version of service B. Okay, the replacement cannot affect. Of course, something can go wrong when you replace microservice. So we need to be prepared for failure. And because each microservice needs to be your own data, the reason is because suppose that you replace service B. You don't need to wait service A to update its database, right? So service A and service B have their own database. So these are some principles of microservices. So let's think about, let's review something about OpenShift and Kubernetes. When I say OpenShift, OpenShift is distribution of Kubernetes. So let's see how can we deploy a Java application inside a cluster. Okay, so I have here OpenShift running. I have a project called Tutorial, which has 2 microservices deployed. One called customer and another called preference. It's a service A calling service B. And now I will deploy a service called recommendations, which is the service C. Okay? And by the way, let me open a visualization so you can understand what I'm saying. So there is a project called Kiali. Kiali provides a console where you can visualize those microservices. Okay, so we have microservice A calling microservice B, customer calling preference. And I can even, look here at something that's interesting. I can show the traffic rate per second, I can show traffic animation, and I will send some requests to customer. Customer will try to call preference, and preference will call the service recommendation that's not available at this moment, okay? So in a couple of seconds, you will see some errors happening in this console. Yeah, you can see here. It's because it tries to access recommendation, and recommendation is not there. So 100% of the traffic is making this path. So let's deploy recommendation, okay? I have, let's build our project here. Maven package, that's what you will do to create your fat jar, right? Now that we have our jar file here, OS target recommendation.jar, we have also a Docker file that will copy this recommendation.jar to inside our container. That's familiar to you because you know Docker, right? So let's use Docker build and create a tag called recommendation v1. That's my tag. So let's build it. OK, I have now a container, an image. And now, to deploy something inside Kubernetes, I can have a deployment file Let me open this file here so you can have a look. That specifies the following. I will run one replica of a container called recommendation. Here I have some environment variables. I will use this image here. So by the way, let me update the Docker builds. So it will use example recommendation. OK. And these are the ports. And it has a readiness probe to make sure that the container is healthy. It will try to access this URL. So this is the deployment file of a Kubernetes. So to run this deployment, I can do just kubectl apply -f, and that will cause the deployment of a Kubernetes microservice. So let's see it being created here. So it will start in a couple of seconds. It's saying this now it's running, and because it's running, we should see now we have access to our third microservice, right? And let's see here. In a couple of seconds, we'll have this information being updated here, because it fetches the last minute statistic based on the last on every 15 seconds. Yes, it's going through here. So this is the basic Kubernetes deployment. But let's go further. Imagine the following situation. Imagine that you have a failure on one of these services. What we don't want is to have a cascading failure, right? We need to avoid that. And let's think about the history of microservice. In 2006, Amazon EC2 came to life, so the cloud was born in 2006. In 2011, we had the start of FatJars with Drop Wizard and Vertex. FatJar is something that came in 2011, but became very popular now with Spring Boot. And then Netflix went open source in 2012 with the release of Ribbon, Hystrix, Eureka. And finally, we have everything together. We have containers released in March of 2013 with Docker. In fact, containers is a very ancient technology, but in 2013 it became very popular with Docker. We had Spring Boot using the technologies of FetchR, and now with Kubernetes and microservice, it creates the perfect storm for microservice, right? We have containers, we have FetchRs, we have technologies from Netflix that provide service discovery, load balancer, circuit breakers, fail-safe, and everything. So every microservice now, if you are using Service A needs to provide discovery, load balancer, resilience, metrics, tracing. Then it needs to access Service B, that it will also provide service discovery, load balancer, resilience, metrics, tracing, and the same for Service C, right? But what's wrong with Netflix OSS? It's Java only. It's a library that you need to add to your project to provide all those things, to provide resilience, load balancer, circuit breaker, all those functionalities. And when we are talking about microservice, we are not only talking about Java. We need to consider that we can run JavaScript, we can run Go, we can run Ruby, we can run Python. So we need to provide for each microservice the definition of the API, how that service will be discovered, How we will perform invocation on that microservice. Is it REST? Is it messaging? Elasticity, resilience, a pipeline to deploy that microservice. How we will authenticate that microservice, authentication, logging, monitoring, tracing. All those things should be provided for each microservice on your cluster, right? So fortunately, with OpenShift and Kubernetes, you can have that for free. You don't need to use Netflix OSS anymore. So with Kubernetes, you have discovery for free, you have invocation for free, you have elasticity for free. So for example, here in my code, you see that I don't have anything else to have preference finding recommendation or vice versa. Let me show you something here. If I open a console here, I can do ping recommendation. It will resolve the IP address of recommendation for free because there is internal DNS inside Kubernetes cluster. We have elasticity. So for example, if I want to scale recommendation to 3 replicas, it's easy, it's simple. And you will see that once the new replicas start, you should see them answering here. So let's wait a couple of minutes. Yeah, now we have 2 new replicas in our cluster. This is the number of the name of the host itself, right? If we come here, and we'll see that we have the host for 2 JFK, PDZ, FH, and they are all deployed here. And this is the number of, it's a counter, just simple as that. So and now I can reduce, I can shrink and grow my cluster easily, and now I have only 1 replica running. So this is the beauty that Kubernetes gives you for free. On the other hand, OpenShift also gives you monitoring, logging, and pipeline. Okay, so, and plus, I want to show you Istio. Some people call Istio, Istio. Istio provides you some really nice capabilities. So for example, the purpose is to create a service mesh. So what is service mesh? Service mesh is a dedicated infrastructure for handling traffic between services, right? So the idea is that the complexity of this service communication is provided by someone else other than the application. Let's see that happening. So with Istio, you can have for free tracing, monitoring, authentication, and resilience. Let's see how. Before Istio, we saw that every microservice needed discover, load balance, resilience metrics, tracing, circuit breakers, etc. After Istio, all those capabilities were moved to a sidecar container, a proxy that will intercept the traffic using IP tables. So when the container starts, it runs an IP table rule that redirects all the traffic to a sidecar container. The sidecar container will provide all those functionalities and then invoke your application. So the communication with Istio is provided and intercepted by this sidecar container. This sidecar container intercepts all the network traffic, and it's implemented using a proxy called Envoy. Envoy is a very performatic proxy written in C++. So let me open here the Envoy proxy website. So you can see here that Envoy is an open source edge and service proxy designed for cloud-native application. So when you are running Istio, you are running a proxy written in Envoy. You saw here that a customer has 2 containers inside, the application itself and the proxy. Preference has also 2 containers inside this pod. You have the application and the proxy. But here, the recommendation, I have only the application. So I will show you how to deploy a proxy with the container. First, let me remove the deployment of recommendation. kubectl, remove, oh, it's delete. Yeah. So I deleted recommendation. Okay, now recommendation will start to fail again. Right? So it's now failing. And so with Istio, you don't need to use Netflix OSS. So you don't need to use Eureka, you don't need to use Ribbon, you don't need to use config server, you don't need to use Zool, Hystrix, and it also provides you with open tracing. So it's not only about Java anymore. You have a polyglot microservice platform with Istio. We can write using Node, Spring, Python, and then you will have all those functionalities. So with a service mesh, that communication, you can have intelligent route and load balancing. You can have A/B tests. You can have smart Canary release. We talk about Canary release during this talk. You can test your microservice by causing chaos. You can inject faults. You can have circuit breakers for free. You can have metrics and tracing. I will show you that as well. And how that works. So as I said, first you will deploy a proxy with a side container. And then there is a control plane for Istio that's composed by 3 applications. First is the Istio pilot. Istio pilot will get all the configuration and send to the proxy. So all the proxy will have the rules to work and provide those capabilities. You have also the Istio mixer that receives all the information for rate limits, for monitoring, for tracing, for quota, and you can also have you have Citadel, which provides the mutual TLS between microservices. So that's the control plane, and I have control plane running here. Let me show you. Inside project running Istio, I have my control plane running. The Istio pilot, Prometheus, Citadel, the sidecar injector, everything related to Istio. Okay. So let's talk about blue-green deployment. First, let me inject Istio here so you can have an idea how it works. You saw that first. The first thing that I needed to do was to create a deployment, right? But this deployment was one single container, right? Now, if I want to deploy a sidecar, I need to provide the sidecar container in that file. Istio has a file, has a command called istioctl that I can use this command kubeinject, and I can give the name of the file that will generate a new file with your container. So let me create a second deployment file here. Deployment v2 YAML. If we do a diff between this file, between the original file and the second file that we created, we will see that istioctl included the proxy in this file, right? So the proxy will run in this port with this user. It will mount this path to get the configuration of the proxy. What else? Yeah, basically, that's it. So that's caused when we run this command here, istio kube inject. But we can do everything in one single shot. We can use kube apply and the name of the original file and deploy that file. That will create the deployment v1 with the proxy. So let's see that. Now my recommendation has the proxy included as well. Okay, and once that's deployed and running, we will see v1 replying. Now let's create v2, right? So we can perform different deployments. So let's go. By the way, let's see what's happening here inside Kiali. We'll see HTTP traffic responding. Yep. So now it's v1 is receiving the request. And note here that all the information is sent to Istio. And now let's create v2. I will do a simple change here. I will create v2. Okay. Let's do the same thing again. Maven package. Clean package. Work. Let's perform Docker build. But now let's use the tag v2. Okay. And now let's deploy v2. But instead of using deployment, I have another file here for v2. Okay, v2 has been created. Let's take a look. Yeah, v2 will come to life. Let's see here. Let's wait for v2 to come to life. Yeah, v2 has been deployed. And now we can see v2. It will also start receiving traffic here. Let me use % of total. Yeah. Yeah. We can see here. It's almost 50%. 55 to 45 of the % of the traffic are going to v1 and v2. You can see it here. Okay? Now let's move forward. Let's do some playground with those microservices. The first thing is blue-green deployment. So what is a blue-green deployment? So imagine that you create a build. It will go through the pipeline to development, QA, then you approve, go to the staging, someone tests, and then send it to production. It will send to an environment. Some people can deploy that to a green environment. Some people can deploy to the blue environment. And then you just switch the key between one version and another. By default, as you saw here, Kubernetes will send the traffic to both versions, right? And the idea is, if something goes wrong, you'll just switch the traffic from one version to another. So you can see here, the traffic is going to v1 and v2. With Istio, I can use YAML files to specify what is the traffic. In fact, I need two files. One file creates the destination rule. What is a destination rule? It's just an internal name for Istio. So if we look here, for recommendation, we created two subsets, one called version v1, another called version v2, and they are based on the labels of a container. So I have the label version 1 and version 2. We can solve those labels here. So let me show. Recommendation v2. The label is here, version v2. So it matches with here, version v2. For v1, we have the same thing. This is the label, version v1. So it matches to version v1. Okay, so I created two subsets, and now the second file is the virtual service. So when the traffic goes to recommendation, I can see now, I can specify, for example, that we'll send 100% of the traffic to version v2. So let's apply those two files here. Copy, Istio create, it's very simple, Istio CTL, or Istio control, Istio cuddle, people use different names. I will specify those two files. And note here that once that I apply those files, only v2 will receive the traffic. Okay, created. Now you can see that only v2 is receiving the traffic. And we take a look at Kiali. We will see that Kiali uses the data from the last minute, as you can see here. So during 1 minute, we will see that the traffic here is moving from v1 to v2. Okay, but in real, only v2 is receiving the traffic. Okay, this is just for statistics. So for a statistic, you will see in 1 minute that every traffic, in the last minute, now 83% of the traffic went to v2 versus 17% of v1. Let's refresh. 97%. Let's refresh again. Yeah. All the traffic is going to v2. Now, let's move that to v1. For v1, I just need to replace my virtual service. My virtual service now, instead of going 100% for v2, I will say that I want to go 100% to v1. So let's replace my virtual service. Note here that once that I apply the rule, every traffic is now going to v1. Simple as that. I didn't change the code. I only changed the virtual service created by this network, this mesh, this service mesh, and that is possible because the sidecar container is intercepting the traffic. Not only the inbound traffic, but the outbound traffic as well. So when I specify that, the service here, preference v1, knows that instead of calling v2, it needs now to call v1. That is specified in the proxy. It's an inbound and outbound proxy. Okay, let's refresh. In 1 minute, we'll see that the statistic says that the recommendation v1 is receiving all the traffic. Although here we can see that only v1 is receiving the traffic. Of course, if I want to return to the original state, I can delete the virtual service, and now, once that I delete both, there is no rule, there is no virtual service defined, so the default behavior is send 50% of the traffic to v1 and v2, v1 and v2. That's what's happening here. Okay, and then once that it refreshes, we will see that both traffic is receiving 50%. That's the blue-green deployment. What about Canary deployment? Canary, do you know that why it's called Canary deployment? It's funny because the British miners, they used to carry a small canary to inside the mine, because the canary is very sensitive to gas leakage. Any sign of gas, the canary will die. It's a shame, right? So the idea is, if the canary dies, there is a problem. There is a gas leakage. So people should run as fast as possible from the gas mine. So they use this concept of canary in software as well, because once that you get your new version, you introduce it as a small portion is a Canary version. And if everything is OK, then you can increase the number of requests on the Canary. Of course, if the Canary dies, you remove the Canary from your code. So that's the idea. Only a certain amount of traffic will go to a Canary version. Canaries with Kubernetes is always based on the number of replicas. So usually, as it's like you see here, V1 receives 50% of the traffic, V2 receives 50% of the traffic, just like here, unless you increase the number of replicas, right? Suppose that I want 1/4 going to V1 and 3/4 going to V2. What I will do is control that based on number of replicas. So now V2 has 3 replicas, and V1 has 1 replica. So once that it starts, you will see 1 replica going to V1, 3 requests going to V2, and 1 request going to V1. That's how Kubernetes works. But that's not what I want to do. I don't want to control the number of replicas. I just want to have 1 replica and 1 replica, right? And then I want to use Istio to control the number of requests. So with Istio, I can have 1 replica and 1 replica, and because I'm managing the traffic, I can say, just send 10% to V2 and 9% to V1. Again, that's possible using Istio rules. So I will create a virtual service that can say 9% of the time of the route go to version 1, 92% of the traffic go to V2. So let's apply this rule here. Note, I have 50%. When I apply the rule, now you will see, come on, yeah, 9% of the time, V1 will receive the request, and only 10% of the time, only V2 will receive the request. You can see that V1, V1, now V2. V1, 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 then V2. 9% of the traffic. Suppose that I want to change that to 75-25. Right? Just like here. What I do? I replace this file. Using what command? istio-ctl replace. Now, oops. Now you will see that V2 will come more frequently, like 1/4 of the time. So V2, V1, 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 V2, V2, V1, V2. Now V2 comes, it receives 25% of the traffic versus 75. So it's really cool how Istio can manage. By the way, for those who are worried with the Canary, there was the Canary Resuscitator. Because, yeah, people on that time, they were concerned about taking a canary to die. So they used a small cylinder with oxygen. So when the canary died, it was not died for real. It was just passed away. It was just not breathing. Then you open the cylinder with oxygen, and then the canary can breathe, and then you take the canary away, and you as well, okay? So don't worry with the canary. Most of the time, he survived. With Istio, you can also have monitoring for free. So if you take a look on the, let me open here. Let me open Prometheus. With Prometheus, you can use some information from your microservice. You can also use Grafana. I think Grafana is much more interesting because Grafana you will see graphics. So for example, I want to see my mesh. No, let me see. My workload. So in a name, let me see. Service. It's outdated. So because I started and restarted my computer, it probably lost the details of the monitoring. What else? You can have tracing. Tracing is really interesting because you also have that for free. So let me open tracing here. Tracing uses Jagger, so you can see that it creates the details of your microservice. How many? This number is the number of invocations. Customer invoked preference that invoked 3,000 times, 298 times recommendation, and you can even look inside the tracing. So I want to find everything that came through customer. Let me see. Last hour, last 2 days. Yeah. It's because I restarted my machine also. I lost the tracing. But you could look at all the tracings with Istio. And plus, we have the project Kiali, which I'm showing here, that provides you the statistics. And not only the statistics, but you can see the health of the application. You can open application and see what rules have been applied, what are the virtual service and destination service. And because we have a little bit more time, let me show you something interesting, which is Canary Deployment based on the user agent. So suppose that you want to have one version that's available only for people that are using Internet Explorer, and another version that will be accessible for everyone else. So let's do the following. Let me send all the traffic to V1. Oops, let me clean first. Scripts, clean, let me clean everything. Okay, now I want to send everything to V1. Okay, only V1 is receiving the traffic. Now I want, for example, Safari is the browser of macOS. I can do the following. Only if my user agent contains Safari, I will send to V2. Otherwise, I send my request to V1. Since I'm using curl here, curl is receiving V1. If I open V2, so let me open V2 here. If I open my microservice, let me apply the rule. I forgot about that. Now I want everyone else to go to V2. Everyone that has the Safari browser will see V2. So let me refresh. Yep, I'm seeing V2 because I'm using Safari as a browser. And people are receiving V1. To prove that, I can use, for example, the curl command with Safari. If I use Safari, I will see V2. If I use the user agent Firefox, I will see V1. Okay, that's possible to do as well. In this tutorial that I'm using here, you see also different use cases. You can see how to perform dark launches. Do you know what is a dark launch? Dark launch is very famous. One use case that's very famous is the one used by Facebook Messenger. Facebook Messenger was released like 1 year before we see it live. How that happened? They released Facebook Messenger, but you couldn't access it directly. You couldn't see it. But every traffic, every message was being redirected to Facebook Messenger so they can try, find all bugs, see if it could scale. And then one day they just turned on. That's called dark launch. You don't see it. It's launched, but you don't see it. Let me see how you can perform dark launches with Istio. First, let's clean all rules, right? Now we have V1 and V2. And let's do a dark launch. Mirroring traffic. Yeah, dark launch. We can see that we have 2 replicas, right? We have V1 and V2, right? Now, what I will do is send all the traffic, apply this rule here. Look here. All the requests will go to V1, but it will mirror the request to V2. You will not see the V2 replying, but but V2 will receive the traffic anyway. So let's apply that. Okay. Now only V1 is you see the reply only from V1, right? But let's take a look on V2 log. kubectl get pods, so I can see the name of the pod. Now let's take a look on the pod of V2. kubectl logs follow this log. And I have 2 containers here. I want to use the container recommendation. So you can see V1 is receiving the traffic, but V2 is also receiving the traffic. But you only see the response from V1. This is an example of dark launch. Okay, let's clean everything again. Okay, now we have the request going to V1 and V2. If we take a look on the log, both are receiving the requests. You can also try to inject fault, like you can make one microservice to behave badly. You can make one microservice to return always 503. You can have one microservice having a delay. So for example, let's make V2 have a delay here, because this file specifies a delay of 7 seconds, 50% of the time. So let's apply that rule. It's applying the rule. So it will take like 7 seconds to reply. Probably it died because of the timeout. There's a timeout between the communication. Let's see what kind of failure. We can have rate limit. So I don't want, because if someone tries to hit your microservice very badly, you can create a rate limit. So for example, I want 5,000, let me see. On V2, I want maximum of 1 request per second. So let's apply that rule. So let's wait. In a couple of seconds, you will see that it will say, you are sending too many requests on my V2. So let's wait. It's because it's hard to get more than 1 request per second here. And I need to apply this other rule here. Oops. Because this rule is the one that creates the count of requests and a quota for it. I forgot to apply that rule as well. So let's see. Yeah, resource exhausted. So the proxy avoids more than one request per second on V2. So you can protect your microservice. So you have many things that you can do without having to change your code. You can create circuit breakers, retries. A service tries to communicate with another service. The service is offline, so it will retry. You can provide delays, timeouts. You can create pull ejection. If the microservice is not responding, then avoid that microservice for 10 seconds, for 1 minute. So all those things are possible with Istio. By the way, if you look at Istio a lot, as I did, as I'm showing to you, you can download this free ebook. It's really for free. You just go to this link, okay, minutes for pictures. And then you just provide your name, your username, you do a registration at the Red Hat Developers Program, and you download the book for free. We just need your email. And I promise, it's not for spam. You will receive an email from Red Hat like once in a month saying, these are the really cool things for developers that was released this month. And also, you can try Istio using that tutorial and going through this link, bit.ly/Istio tutorial. Seconds for picture. Ta-da. If you go here, you will see a GitHub with the source code of customer, recommendation, and preference. By the way, if you go to each microservice, you see a Java implementation, a Node.js implementation. With Java, you can see Camel, Microprofile, Spring Boot, Vertex. Because what I want to show is that no matter what language you are using, no matter, because these capabilities is not inside a language. It's not inside the library. All those capacities are defined in the YAML file that they are here. Hold on a second. Documentation, preference. Where are they? Yeah, Istio files. It's here. So you can try how to create blacklist, whitelist, role-based access control, different faults like 503 delays, timeouts, and everything else. And plus, in this GitHub link here, the Istio tutorial, there is a HTML version that I've used, so you can learn how to set up an environment on your computer using Minishift. Minishift is just like Minikube. The difference is that a Minishift provides also OpenShift. OpenShift is what I'm using here, is the OpenShift Kubernetes distribution. Okay, so you create Minishift, you will deploy the microservices using something that you are very familiar with, and I just did here. You go to an implementation, do a Maven clean, do a Docker build, and then you set up the microservice. Then you can try all the things like monitoring. You can try simple routing rules, which I did. You can try advanced routing and perform like mirroring, dark launches, Canary, load balancer, rate limit. I did it here as well. Fault injection, circuit breaker, egress. And also there are some advanced Istio use cases like service virtualization, mutual TLS authentication between microservices, end-user authentication, role-based access control, dark launch with automatic tests. All those things are in this tutorial for free. Just try, just go to that URL. And of course, I would say that this is the end, but serverless is coming. Oh, thank you. And we have 4 minutes for questions. Maybe you saw something that you really want to go deeper or have a better explanation. Questions? 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 Question? Sure. Great questions. Great question. The question is, does it work only with Kubernetes? Yes, Istio is, uses one characteristic of Kubernetes, which is running 2 containers in a single pod. Kubernetes has this concept of pod. It's not called you run a container, you run a pod. Pod is an English word that means a collection of whales. And whale is the logo of Docker, right? So that's the idea. Inside one pod, you can have multiple containers. So inside one pod, this pod here, I have the container customer running my application, and I have my container running the Istio proxy, Envoy. So this is only possible inside Kubernetes. At the Istio tutorial, if I'm not wrong, they will provide this feature also for Nomad and Console. Okay, but essentially, the implementation now is only for Kubernetes. Okay? Well, our time is over. So, okay. The proxy or the Istio? Istio. The question is, does it work on any network? When you install Kubernetes, it creates a software-defined network. So it uses Istio, it uses Kubernetes software-defined network to operate. So it's not every network. It's only a software-defined network inside Kubernetes. So it's really attached to Kubernetes technology. Thank you as well. Okay.